Good morning. We are going to present our final project of differential equations, which is the mixture of two salty solutions. And the team is conformed by Mario Garcia, Juan Francisco Borrego, and Estefania Rodriguez. First of all, the objective of the project was to apply a differential equation of the mixture of two salty solutions in a container in order to see if it is resolved and if it applies all the concepts that we want to do. With this experiment, we are going to be able to see the amount of salt that is present in a mixture of salt in a container of water. And the water and the container has an entrance of water, and at the same time has an exit of water. The schematic representation of the experiment is with the next steps. First of all, we have to obtain and solve the differential equation of the problem. Then we have to realize the experiment with all the information that we want to do or to prove. Then we gather the information from the realization of the experiment with all the items that we have. And finally, we analyze the data in order to see that if the equation is proved or not. And in the image down, you can see a representation of the experiment. Now the equation solving. First, we have the entrance concentration, which is equal to salt concentration plus the entrance reason of water. Then the exit constant is AT divided by 2 libras, which is the same as pounds, over gallons. Then the differential of A over the differential of T is equals to the salt reason entrance minus the salt reason exit. Then the exit salt concentration is the exit constant plus the entrance reason. And here is shown with the exit constant how we obtain it. That is the entrance concentration, that is equal to 0.221 libras, which is the same as pounds per gallon, multiplying 0.30 gallons per minute. That gives us an equal concentration of 0.066 liters per minute. Then we have the exit salt concentration, which is equals to 18 above 2 pounds per gallon, multiplying 0.30 gallons per minute, which gives us an equal of 80 above 6.66 pounds per minute. Then we have differential of A above differential of T equal to 0.066 minus 80 above 6.66, which gives us an equal of dA above dt plus 1 above 6.66 multiplied by A equal to 0.66. Then when A with T0 is equals to 1, we have the next integration. And we proceed to make this integration in order to obtain this, that is E elevated to T above 6.66a equal 0.4395 E elevated to T above 6.66. Then with the conditions, when the time is equals to 0 and A is equals to 1, we have that A equals 0.43956 E elevated to T above 6.66 plus C. Then with the a equals to 1, we substitute the these terms, and we have that c is our constant is equal to 0.56044. Then we know that a with the constant substituting in the formula, we know that a equals to 0.43956 e elevated to t above 6.66 plus the constant that is 0.56044 plus the multiplicating 1 above e elevated to time to t above 6.66. Then a is equal to 0.43956 plus the constant dividing e elevated to t above 6.66. Then we have that our result is at equal to 0.43956 plus 0.56044e elevated to minus t above 6.66. Then here we have the graphics. This one were the ones that we run in the first test and the second test. Both of them were with different amounts of salt in the water.
During this experiment, we learned that differential equations are useful in real life, or in this case, in the experiment we work on. Also, this helps us to understand the change in this process or this experiment during the pass of the time, and prove if it is correct with the help of the differential equation methods that we learned during the class.
This project, I think, was very interesting because we did things that we think, that I personally think that we didn't going to make. This taught me that the equations can be applied very easily into daily situations and daily stuff like this mixture, and that it can be applied in all kinds of science.
This project for me was very interesting because first we selected a problem that was uh, salt mesclation. Then we made the problem with a bottle of water and a bucket salt, and then we resolved the problem with our calculation that the video explained. This project for me was very interesting that we apply the differential equation.